Alright, from last night's homework, it's problem 71. What I did, I don't know what you guys did to solve this. You got the right answer, I think was in the back of the book. But I took this first part here, I took that, and I solved it first. So I went over to the side, 3 plus I over 4 plus I. And I'll put those in parentheses. And we multiply that by the conjugate of the denominator, which is 4 minus I. And I'll multiply top and bottom by the same thing. So I'm multiplying by 1. Let's do denominator first. We have 4 times 4 is 16. I times negative I is negative I squared, which that's going to turn into a positive 1, which is going to make my denominator 17. I squared is negative 1. In the numerator, I'm going to use FOIL. 3 times 4, 3 times negative I times 4, and I times negative I, which is negative I squared. And I know the negative I squared is a positive 1. Add that to the 12, and I'll get 13. Combine my middle terms, negative 3I plus 4I, give you 1I. And so that's what this first term is equal to. This is equal to 13 plus I over 17. And if you do that first, it might make the rest of the problem a little simpler, because now I can add 1 to it, but I'm going to make 1 17 over 17 because I have fractions. And then I'm going to make I 17I over 17 so that we have common denominators. My answer is going to contain the common denominator of 17. And in the numerator, I'll combine like terms. So 13 plus 17 is 30. I plus 17I is 18I. And now I'm going to put this in the form A plus BI, and we can split it up. 30 over 17 plus 18 over 17 I. That was problem 71. Do you guys have any questions on any of the others? Okay, so yeah. 59, is that the one with the fraction? No, 2 minus 3I square root of 2. So 59 is 2 minus 3I square root of 2, quantity squared. And what I suggested yesterday is that you break it up this way, 2 minus 3I square root of 2, and then use FOIL. The tricky part is FOIL here. Right? Well, 2 times 2 is 4. 2 times negative 3I square root of 2 is negative 6I square root of 2. Okay, do you follow that? 2 times negative 3I square root of 2 is simply negative 6I. And then I'll multiply these two terms together, and I'll have also another negative 6I square root of 2. And then the last two terms. Well, first of all, the negative times a negative will make this a positive. 3I times 3I is 9I squared. And the square root of 2 times the square root of 2 is the square root of 4. Okay? Which is 2. So now I have 4. Combine these two terms, and I'll get negative 12I square root of 2. And the square root of 4 is 2. 2 times 9 is 18. So 18I squared. which of course this is negative 18. And 4 minus 18 is negative 14 minus 12i square root of 2. That's all you can do. Yes?
Okay, so for like those type of problems, you can't just apply the square to everything. You have to like.
That's correct. You have, because when you're squaring a parenthesis, that means you're not squaring each term inside here. If we didn't have the subtraction here, then you could apply it to every term. But if we're adding or subtracting inside the parenthesis, you have to separate them and use FOIL. Okay. Any other questions? Are you okay with the fraction? Yes? Good, a yes? Okay, then what did you do with that fraction? And that's problem number 67.
I didn't like multiply it out, so I just got like 8/3 over 25/36 minus 2/3 I over 5/36.
The answer, did you get the answer in the back of the book? Okay. Let me show you guys an easier way to do this problem. This is problem, what did I say it was, 67? Okay. I don't like dealing with these fractions because you found out it's a nightmare. So let's get rid of these fractions. And so if I multiply by the common denominator of 3 and 2, which is 6, I'm going to multiply that fraction by 1, but I'm going to make it 6 over 6. And it makes this a much easier problem. I'll distribute the top 6. 6 times 4 is 24. 6 times 2 is 12. When I multiply 6 times 2/3, what does that equal?
8/3.
Multiply
4.
12/3, which is 4. 2 times 6. So I get 4 minus, and then 1/2 of 6 is 3. And isn't that an easier problem to deal with? Because now I can just multiply top and bottom by the conjugate, which is 4 plus 3i. All right, so it makes this problem a lot easier than dealing with the fraction above. Okay, so we want to simplify that. All right. Any questions? All right. All right, for the new lesson. This is 5.7. How many points does it take to draw a straight line? 2. How many points would it take for a quadratic, for a parabola? 3. All right, so 3 points is not, as long as they are not collinear. All right, it's not, as long as they don't lie all on a straight line. So if we have points like 1, 3, 2, negative 3, and 6, 13. Can you give me an equation of the line that contains those 3 points? And I'm going to show you 2 ways to do that problem. I know that the general form for a quadratic looks like ax squared plus bx plus c equals y, or f of x, either one. Okay, so the information they give us, when x is 1, y is 3. So let's put in 1 for x. 1 squared is 1. I get 1a. Plus, if x is 1, that would give me 1b plus c. And when x is 1, y is 3. I just inserted 1 for x in the general form, and that was the result. Let's put in 2 for x. 2 squared is 4. I get 4a. if x is 2, I would get 2b, or not 2b. And then plus c. See, my other classes laughed, but that's okay. And y is equal to negative 3. It's not really that funny anyway. Okay? So now the last one, this last point, when x is 6, 6 squared is 36. I get 36a plus 6b plus c. I don't know what c is. And that equals 13. So when x is 6, y is 13. And I have a system of equations. And what I'm looking for is a, b, and c so that I can put it in that equation for a, b, and c. And that'll tell me what the quadratic equation is that contains the 3 given points. And how would you find a, b, and c? Matrix. Very good. Okay, we've used matrices. So we would write our coefficient matrix 1, 1, 1, 4, 2, 1, 36, 6, and 1. What I'm looking for is to find a, b, and c, and that equals my constants, which are 3, negative 3, and 13. Okay, we did this last chapter. We put this in our calculator in a matrix. We'll make a matrix A. We'll call the constant matrix, matrix B. And how do we solve it? Perfect. A inverse B. So now if you go over to your calculator, okay, so as we go to our calculator, and I'll pause it. Once you enter A inverse B into your calculator, you'll see that our A is 2, our B is negative 12, and our C is 13. And so the formula then would be 2x squared minus 12x, because that's our B, and then plus 13, and that's our function. And this is the quadratic function that contains the points 1, 3, 2, negative 3, and 6, 13. Fairly simple. All right? That's one way to do the problem. If you like that, go ahead and use it. I have another way to solve that problem. All right? And this is strictly calculator. So I'm going to see if I can explain how to do this. Just talking into the microphone. All right. If you remember, go to your stat menu. You have a stat button. It's in the second row. It's the third button over. And what we want to do is we want to edit. And under L1, we're going to put the x values of the points that I just gave you as 1, 2, and 6. Then I'll scroll over, and under L2, I'm going to put in my y values of the example I just gave you, which is 3, negative 3, and 13. All right? And that's under your stat menu. Now hit your stat button again. And I want to scroll over to calculate. Scroll down to number 5, which is a quadratic regression, a quad REG. And I'll enter on that. And you should have quad REG in your calculator, and hit enter again. And there's your A, B, and C. And that might be a little bit easier, don't you think? Yeah. All right. And so that's just another way to solve the same problem. So your homework for tonight is going to be on pages, let's see, pages 327 and 328, 7 through 19 odd, and 23 through 30 all. And problems 23 through 39, it's really just one problem, but they're going to ask you many questions about that problem. It has to do with shooting a rocket off on Mars. And you should get a negative A term because there's the rocket being shot off on Mars. Then they're going to ask you questions. What's the height of it? How long does it take to get to that height? When does it come down and hit the ground? All right? And then we're talking about feet in this equation. You'll see the chart on the story problem for 23. Okay. So, can you guys tell me what the gravity is on Earth?
9.8.
9.8 is in meters. We're in feet now. When you drop something, how fast does it fall? What is it? Not 16. It drops at 32 feet per second squared. That's gravity. It'll drop at 32 feet per second squared. I'm going to ask you on Monday, and see how much you guys have remembered. I'm going to ask you what the gravitational pull is on Mars. All right? You drop something, I want to know how fast it drops on Mars. Okay? Even though that's not one of the questions I ask you, I'll ask you that on Monday. All right? And that's your lesson.